ever, and I'm grateful.
Tom, I'm 9DJU.
I'm Guy. Just got the call. It was yesterday. What?
Yeah.
Just got the call yesterday.
Yeah.
Oh, really?
So, it's quite unique. It's
KE9.
KE9. Thank you. Yeah. CZZ.
Whoa.
Charlie Zulu
Whoa.
CZZ.
That's a fun one.
So it's either got a Zulu zebra or Zulu.
Oh. Larry, K9KZT.
Mike, K9 Old Uncle Pete.
Jacob, coming soon.
Joe, K9JPP.
And David, W9CJS.
Kilo Bravo 9, Sierra Victor, Mike.
Larry, AC9GM.
And Verna, W9YUM.
All right. Anybody, if it's your first time coming to RARA meeting, why don't you raise your hand so that we can say welcome? Oh, well done. So thank you, everybody, for coming. We're really glad that you're here. Can we have the minutes of the last meeting, please?
So you want me to read those? Okay.
Yes, please.
You should have memorized.
Ha ha. The meeting was called to order at 7:03 by Verna. The meeting was held via Google Meet. A welcome was extended to all. We had approximately 15 members in attendance. The minutes from the previous meeting were read by myself. Motion was made by Larry Schubert and seconded by Mike Richardson. The motion passed. The treasurer's report was read by Verna Schubert. The period reported on was the month of February. The opening balance was $5,454.52. Total income was $374.75. Total expense was $567 for annual insurance payment. The total was $52.62. Current balance as of the meeting was $5,301. Kurt Eversole made a motion, and Jamie Curtis then seconded the motion. The motion passed. There is no new business. Larry Lyle brought up his swap meet dated for Sunday, May 18th. It will be held at the Winnebago County Forest Preserve. And then Verna discussed the event that is following the swap meet at the same location at 1 p.m. on May 18th. Business meeting was closed at 7:20 by Verna Schubert. The presentation was done by Kurt Eversole. The presentation was on repurposing uninterruptible power supplies.
Okay, any additions or corrections?
I have a correction.
Okay.
It's the Hononegah Forest Preserve. That is right, isn't it, Larry?
Yeah,
Yes.
Hononegah, not Winnebago. Sorry about that. I will make that correction.
Matt, I'd like to make a motion to approve it.
Well, I just want to make sure there's no other corrections first, and then I'll take that motion. Any other corrections or additions? Okay.
Move to
Gordon made a motion
Make a
to,
motion to approve it. as read.
Second.
Mike Perry made a second. All those in favor, aye?
Aye.
Opposed? Okay, motion carried. Thank you. We got the minutes, treasurer's report, please.
Okay, this report's for the month of March. The beginning balance was $5,262. Total income $137.75. That was primarily new memberships and renewals. There were no expenses. The closing balance was $5,400.
Thank you, Verna. Is there a motion to accept? Larry Lyle, and then seconded by Jimmy Curtis. All those in favor, aye?
Aye.
Opposed? Okay, motion carried, thank you. We're gonna go into, the old business. May 18th at Hananiga Forest Preserve is the swap meet. Did you wanna mention anything about that, Larry?
For those that aren't familiar with it, there's no VE testing, no vendors, no cost. Everything's free. It's just a bunch of hands getting together to swap stuff and tell lies. Yeah, right, first time. So come on out, 9 to noon, rain or shine. There's cover and so forth. There is electricity if you want to demonstrate your weight or something like that or something. And on a couple of the nets we have swap meets or something like that. Why don't you mention anything you want people to bring? You know, a lot of times you go up to somebody and say, "You got any thermostats?" No, I didn't bring any thermostats. They're all over the basement now. I brought them last week and they did, or last year and they didn't sell. So tell people if you want something. A bucket of gold would be good.
Yes, that would be good.
Yeah.
At silver price.
All right, thank you, Larry. Gordon, do you have a question?
Yeah, I know there was something mentioned about 1 o'clock, we might have something going on, you guys had that firmed up yet or not, or?
Yes.
Yeah, I'm not sure it'll be like 12:30 or 1, I'm gonna firm that up. But what it is, just so everybody can hear me, is we're doing a joint, kind of an educational thing with the Greater Beloit Amateur Radio Club. And it will be at Hananiga, and it's going to be a building of tape measure antennas. And Chuck Bell from the Beloit Club is going to spearhead that. Brett from the Beloit Club, following the construction project, is going to do kind of a mini fox hunt at the park, because we've had people that are interested in fox hunts and how all of that works. From RARA is Jimmy Curtis will be helping with that, and Larry Schubert, and who am I missing from RARA? Seems like there was somebody, well. And there's somebody else, I know I'm missing them, and sorry about that, whoever you are. But tomorrow morning at Denny's in Beloit, we're gonna have the planning meeting, just to get the supplies down, what we need and all that kind of stuff. And just as a side note, we have a number of people that actually are members of RARA and the Beloit Club.
Well,
Yeah,
is there another meeting before that swap meet? I wasn't.
the swap fest.
Yes. Will there be another meeting before that? Because I don't know if
Which
people-
kind of meeting?
This type of meeting.
Yes.
Yeah,
There is one more, right?
yeah.
Okay, because I'm thinking some that want to do it and build an antenna may want to bring a handheld too, because you use that in conjunction with the antennas.
Correct, and we're gonna talk about that
Okay.
at breakfast, and you certainly
I'll
be
probably
part
be
of
there
that.
tomorrow.
But we've talked about bringing their handhelds, we have extra handhelds,
Okay.
and what type of connectors and all that kind of stuff, so.
And that's May 18th?
May 18th, it's Sunday, and we are gonna have hot dogs in between the swap fest and the other things, so you know.
Okay, I just was gonna ask everybody to end the swap meet at noon, so we don't kind of run into the other one, okay? You know, I don't want people still hanging around swapping stuff and so forth while you're trying to make the presentation. If that's okay with everybody.
Thanks, Larry and Vern, I appreciate the information. I'm gonna put out a save the date here real quick, summer field day. That is June 28th and 29th, I'm just confirming that. That's a Saturday and Sunday, more information to follow. We'll have some sign-up sheets, we'll have them online as well as in person. And so that's just a save the date, June 28th and 29th, summer field day.
Do you think that might be at Camp Winnebago again?
it's definitely at Camp Winnebago. I do have it reserved.
Okay, all right.
Yep. So anybody that doesn't know where Camp Winnebago is at, North Main Street, going out of town, just past Harlem on the left-hand side, on the west side of the road there. So, a quick reminder, it's been in 2 ham rags and discussed the Starved Rock Marathon. If you're interested in doing that, if you go through the Facebook page and click on the link, there's a sign up there if you would like to be a ham radio operator. For those that don't know, it's there will be stations of ham radio operators at aid stations or it's different mile markers and all that for safety.
What
So,
day is that?
May 10th. Mhm. Okay, I know I'm forgetting something here. The sign-in sheet, did everybody get a chance to sign the sign-in sheet?
For the event here now?
No, for tonight.
Oh, no, I'm not.
Did you?
No? Okay.
The Starved Rock, is there a race down there, or is that what?
Marathon.
For the marathon?
It's a marathon, yeah.
Marathon, okay,
Yep.
all right.
Yep. So, sign-in sheet. I guess we'll move on to new business. Any new business?
Who else needs a sign-in sheet for tonight? Okay? Thank you.
Matt, do you know if there's, how many people from this area are going down Starved Rock, that people wanna, carpool to go down there, anything like that?
As far as I know, there's 2 of us,
Okay.
right?
Oh, you and Verna?
Yes.
Oh, okay, all right.
Right.
Okay.
Yeah. Yeah, so, if you've never done anything like that before, I did the Chicago Marathon. It was the first thing like that I ever did. It was pretty cool.
Everything simplex?
No, well, I don't know, I don't have a band plan yet.
Oh, all
Right,
right.
so for Chicago, no, because all the buildings, you gotta
Right,
have
yeah,
theaters
it's
all
all
over
over
the
there,
place,
yeah.
right?
Okay, but I didn't know it on there if it could be simplex, or whether it was an area repeater or more.
Probably an area repeater, I'm guessing, so,
They did say, though, to make sure you know how to use simplex on your radio.
Okay,
Yeah.
all right.
be able to program on the fly. I mean, it's really important that you understand how to do that, right?
Right.
And,
Mhm.
yep, okay, PLs and all that offsets. Yep.
Thank you.
Mhm. Okay. Any other new business? What am I know I'm forgetting something, but, no? Does anybody else have anything in?
I'll second it. I'll second.
Gordon and Larry Lyle? Okay. All right, all in favor, aye?
Aye.
Opposed? Okay, we will go into our presentation. Dave?
Who?
Mr. Downer? Okay. Mr. CJS?
Hi, y'all. Good to see you all tonight. I'm going to talk tonight about some things you probably already know. I hope to present them in a little different way. Turn my mic on. I thought I was loud enough. Oh, okay. And if you differ with me, that's okay. There's a lot of myths about antenna, a lot of misunderstanding. I'm going to try to put some of those to rest tonight. So for some of you, it might be a little boring. Something you already know and probably know very well, probably know better than I do. Antennas. What the heck is an antenna? What's the purpose of an antenna for transmitting? What? Radiate. How do you do that? The purpose of transmitting with your antenna is to put as much electromagnetic energy into we used to call it the ether. Yeah, we don't call it ether anymore. How about on receive? What's the purpose of the antenna?
To receive the signal and send it to the radio.
That is true, but there's something more. Most of us hear a signal coming in, and we decide that's a little weak, so we reach over and turn the RF gain up or hit the button for the preamp. And you know what happens? Signal comes up, and the noise comes up right after. If you can hear the hiss noise, that is as much as you can hear unless you've got FT8 or one of those other signal processors that dig down into the noise and pull the signal out. If you can hear the hiss noise, that is the signal. That's the noise floor. So when you bring up your end, put your preamp on, up comes the noise and up comes the signal. So the purpose of your receive antenna is to give the best possible S to N, signal to noise ratio. And you can usually get that by backing off the RF gain a bit. Not too much, 10, 20% maybe. But as you back that down, if you watch your band scope, you will see that white noise starts to go down a little bit. And if you measure it, you'll find that the signal is a little bit louder in comparison to the noise floor. This is a well-known thing. I haven't invented it. Most of what I know I've read or talked to others and learned from them. So I'm going to go on that term called resonance. We all know what that is. We have a resonant antenna. What does it mean? Well, in the dictionary I looked it up and it says materials to oscillate. It's a natural tendency. Well, let's see. So I had one. Okay. I've got here a bottle of Propel. You won't mind if I take a swig, will you? I like Propel. I like black cherry best of all. Actually, I have an organ pipe. I don't know if it will sound, but and the more Propel I drink, the longer the air column, the lower the pitch. Going down. And so on. Pipe. That's the way organ pipe, fundamental frequency, but the shape and the humidity and all of those things take a part in it. Did you ever think about swinging your great-granddaughter on the swing? You do, and you get out there and you swing her going to a very high amplitude with very little effort. But if you push her at the wrong time, it just kind of jiggles a little bit and may move back and forth. You're trying to reach the resonant point of the swing. So you've learned long ago to push it at just the right time. How about a guitar string? You adjust the guitar string, depends on the length of the string and the mass per unit length of the string and the tension in the string, and bing, you get a lovely sound from plucking that string. It is resonant. There is a natural frequency for most materials to oscillate, and you have found it. How many of you have ever been to the Bay of Fundy up in the Maritime Provinces? The Bay of Fundy is a bay up off of Newfoundland or whatever, it's in that area. We were up there and we went across the bridge and the water was under the bridge, maybe 8 feet. We came back 6 hours later and the water was down about 50 feet. And so we were able to go down the stairs. Did you go down the stairs, Jimmy, and walk around in those caves? Yeah, we did too. It's interesting. Why do you have a 53-foot maximum tide down 6 feet? Every 6 hours that happens. Why is it? Because the Bay of Fundy is resonant with the frequency of the incoming ocean waves. And it just kind of resonates in the water. When the water hits in, starts to back out, another wave pushes it in, and the ultimate goal is it comes up 50 feet, 54 feet. I think 53 something is the maximum. It's amazing. How about your voice? You have little tissues here which spread, and when you speak, they go together and you blow air through them. And just like a double reed musical instrument, like say a double reed like an oboe, two little reeds that you pinch with your lips and blow, and they vibrate. And the same is true in an oboe and a bassoon and an English horn. How about your antenna? It's resonant too, but not necessarily mechanical. It's resonant electrically. Now, what does it depend on? Well, what is the wavelength of the signal you're putting on the antenna, and what's the length of the antenna? Obviously, what you want to do is you want to feed energy to it so that it will oscillate at its natural tendency. It is approximately a half of a wave on 80 meters, and guess what? If you feed an 80 meter signal in, it just starts oscillating. What oscillates? The current goes up and down, and the voltage goes up and down, opposite. There's an interesting thing about this. You may never have thought about it. No matter where you measure your antenna, if you multiply the voltage at that instant, let's say it's 100 watts, no matter where you're collecting here in peak voltage to the current or the peak current to the voltage, the product is always 100 watts if you're feeding it 100 watts. All right, resonant. One thing that I learned by reading recently, we talk about anything will work with antennas. You've heard about the contest where they load up a light bulb and they see how many guys they can talk to on a couple-hour period. Anything will work, but anything better by taking care of all the little losses that might occur along the way. In any kind of an antenna, well, if it was 8 feet long, it would resonate on approximately 10 meters as a quarter wave. Now, the interesting thing about all antennas is most of the radiation comes from that portion of the antenna where the current is the greatest. And on this antenna, if there's going to be any arcing point, it will be at the top. You might see it during a highly electrified time with the storms coming in, or maybe you're cruising down the road, and if you don't have a little piece of tape or something at the top, you'll see a little corona coming off. So at that end of a corner, from back here, where is this? Down next to the bumper. Can you see why it's so ineffective? The best thing you can do is to get the antenna up. Get it up, put it on the top of the car. Then the car itself acts like a ground plane for you. But you got to remember, the part the highest in a resonant dipole. You're right on, Larry. It's at the center. How do I know that? Because the impedance is low at the center. The current is high, the voltage is low. R is in the center. And what do? We put it on a house here and a tree down there, and then we let it sag in the backyard. And the low point that does the radiation may be 8 feet off the ground. We'd be a lot better off to use it as an inverted V. Put this on the gable of the house, and then to a tree here, and maybe to a flagpole there. If you think about where does the maximum radiation come from? The maximum current point, wherever that may be. Where is the over? Well, at the end, I did a little math, and I'll talk about that in just a moment. But I need to mention to you that when you talk about resonance, there is, in electrical terms, we're talking about the fact that resonance, which is opposition to the flow of any kind of current, but there is also opposition to the flow of AC or RF, and that might be inductive and cosines of theta. Let's pretend that the antenna we're talking about is always resonant. That means the match. And so what you have left is the radiation resistance, and I'll mention that in a moment. You have a resistance, and Ohm's law follows. All right? Let's go just a little bit further with it. This thing is 8 feet long. Why? Because it looks very capacitive. So what? So what do we do? Well, we find ourselves a little coil, like a hustler coil, and put that somewhere in the center, I didn't bring the bottom part. And now I have capacitive reactance because I have a wire too short, but it's not have a wire too short, but it's nice land or your car, you know that you can tune the variable amount of inductance here and tune any band from 80 through 10 with no difficulty. I did that for years and it worked very well. And tune any band from 80 through 10 with no difficulty. I did that for years and it worked very well. Let's talk about a term which people get a little bit concerned about. We talk about isotropic antennas. What does iso mean? Separated. Iso. What does tropic mean? Earth-like. What is the troposphere? That's where the storms are. That's where their atmosphere is. And above that is the strata. Take a dipole. Now remember, it's resonant. Let's make it resonant at 14.2, okay, on 20 meters. And you get resonant at 14.2, okay, on 20 meters. And you take it from storms, no effect from clouds, totally isolated. And if you measure the impedance at the center, you will find it 73 pole down closer to Earth, but close, so maybe a little higher, 30 feet. It's down to 50, so maybe a little higher, 30 feet. It's down to 50 ohms. And if you continue down, it'll get down to about 20. When you get down to about 20, kind of interesting, if you have an NBIS antenna very near the ground, you are likely to have close to 50 ohms. 50, I use the term 50 and the term 72, 73. What 50 and the term 72, 73? What's unique about those numbers? Well, that's how we must accept those numbers. Well, that's how we must accept the one. If you have it, you'll find with calculation that if it's a 50 ohm antenna, if it gives you that 50 ohms, which is not unusual, you will find that the voltage is 73 volts and the current is 1.41 amperes. What's the ratio between those two? 50. What's the product of those two? 100 watts. Can you see the coax? The coax is most efficient, least lossy at the 50 ohm point or the 72 ohm point. There's some coax even at 90. But there's other transmission lines. How about ohm? What does that mean? It's more 450, depending. The manufacturer knows that. So if you want to have minimum loss, what you want to have is a match between 50 ohms and a 50 ohm antenna. The minute you have standing waves, that begins to disappear and you have some other things that work their way in. But I want you to remember, 72 ohm coax is 72 to 1. Start with a coil at a low frequency, it's dead. But as you go up in frequency, its inductive reactance goes way up. Now, if you start with a capacitor at a low frequency, it looks like an open switch. What that point is, 72 ohms, 50 ohms, that is the coax point. You're talking about the equal. I have something I like to work with. Matt, you're up. I have my assistant here.
You up on this thing, are you, Dave?
What? This is the string which I can tie that on in a few moments. This is a little further, please. You can put a pulse above. You will see it reflect back from his hand. Which way did it reflect? Watch it again. If I put the pulse on the bottom, it comes back on the top. Does this say anything to you? If it's open, it looks like a short. I send a series of pulses down here. If I send him at just the right speed, now he's not pumping with his hand, and I'm moving my fingers ever so little bit. We have this antenna in, what is it? Quarter wave? It's a half wave. It's a half wave antenna. This represents the current. The spring represents, say, about the impedance at the 50 ohm coax at the center. If we put it out here, you might have 2,500 volts and 14 mils. The impedance is extremely high. Okay. Now what if I say, well, this works beautifully on 80, I'm going to load it up on 40. What do I have to do? Have I got it now? It's in resonance. I have two half waves, don't I? What's in the middle, current or voltage? Well, they're both, but the current is very high in the middle. I can feed this on, is it 40 or 20? No, at this point the current is very low. I said it wrong. And the voltage is very high. Do it again. All right. Again, he's not pumping and I'm not pumping very hard. Let's see if we can go up to 20 meters. Waves do I have? Should do it across the floor, but not on 80. It's no good on 40 unless I do a lot of fooling around. Here's 80 with high current at the center. Here is 40 with high voltage at the center and low current. So the impedance at the center might be 2,000 ohms. Don't connect 72 ohm coax to it because you're lost. You could feed it. Now, have you ever heard of an OCF antenna? What does OCF stand for? Off-center fed. If you take the graphs of a half wave here on 80 and 40 and 20 and 15 approximation, if you put your coax there, you will have a pretty good match. It's not perfect, turns way down, and because of the mass of this spring here. Want to hold on to that for a minute? Just don't let it go. I'm very dry.
Dave, I have a question.
I didn't get that. Yes.
What about on an end-fed half wave? I've read that they want the coax portion at the ground.
And end fed, keep that low, and that's the reason you can put it on a little stick, and you put the other end up higher, which will bring the average higher. That would be the current portion.
Okay, that's fine.
Are you going to hang on this string for me?
How about you? You want to do it? Sure.
Wrap 2 or 3 turns around. It can be used to open a circuit at a given frequency or to short at a given frequency. And it can be fairly high Q, meaning that it can be pretty discriminating, pretty narrow. If I send a wave on the top, how did it come back before? It means that the stub is open at that end. Can you see how open or short? Thank you very much for your help. Voltage, low current. High voltage, low current. That's the reason you use a 49-to-1 balun at the end of an EFHN antenna, because you might have 2,000 ohms, and if you have a 50-to-1, you're down to what? 40 ohms, which is not too bad for coax. Lines, and the ladder lines can be 300 to 450 ohms. Open wire lines varies. It can be up 600 to 2,000 ohms. We visited HCJB, International Broadcasters, in Quito, Ecuador, and they have transmitted. So there's a lot of power going. It's interesting, and I'll mention this in interest. They use what's called a Sturba curtain, a grounded line in the middle, and then space dipoles on this one side. And the direction of maximum radiation is out. But the interesting thing is, because this is the ground, they run another half megawatt on a different frequency on this side. So they might be on 6 megahertz over here, they might be on 12 megahertz. Either they're a megabyte or half a megawatt or half a megawatt. It was kind of interesting to see that. It's present in an antenna which is too short. That's why we add an inductive coil somewhere near the middle. It doesn't have to be mounted lower. When this little coil down here provides a transmission line which shortens this up and makes it resonant on 440. So it's carefully done. If I use this A, the voltage to current, a 72 ohm coax. What do you think most efficient? 75. It's determined by the material, the dielectric strength, and all, at which that at 100 watts into a half-wave dipole, and it's perfectly resonant, 14.2 in the bottom of the sideband on 20 meters. At 50 ohms, you will measure it at, if you have 100 watts, SWR 1:1, the voltage will meet at 71 volts, and the current will be 1.4 amps at every point along the line. Now what happens is you get a wave away, the voltage is higher than it should be. The minute the current goes up or the voltage goes up, the losses in the coax go up. You 5 and 1.8, 72, it's 100 watts. The product at any point along the line is 100 watts. You can't have WR. If you had 2,000 amps in one of those quarter wave, 2,000 volt, the current may be way, way down, but the product, only by reflection. Where do you get reflections? I have 72 ohm coax. I'm feeding 100 watts. It reaches an antenna which is not 72, it's 50. Instantly, I have some reflected coming back. A lot of people say, oh, I'm going to work that SW power. That isn't the way it works. It doesn't work that way. If you look in the antenna books, there's a nice chart in there we'll show you. Take RG8, typically half dB per 100 foot at 20 meters, okay? If you have an SWR of 2:1, you're going to have an additional 0.2 dB. So you end up with about 1.2 dB, which is 1/3 of an S unit with a standing wave ratio of 2:1. So I have a friend out in the East, he's a K3, and we talk on CW. He's trying to tune a fan dipole. If you've ever tried to do it, they're impossible to tune because each one affects the other two. This is perfect. A third of an S unit. Will you hear it? It's foolishness to work on it because there isn't that much loss. All right. I digress for a moment to talk about one of my favorite topics, is mag loops antenna. Loop with wire are all you need. In this case, I run it with a little 12-volt motor that I bought for 15 bucks. And it tunes it, and the SWR comes right down, very close to 1:1. Works like a charm. Mag loops are a little different animal. They are not electrostatic, they are electromagnetic, and you treat them differently. They have a concern. They say, if the loop is this big, measure the diameter, the pickup or driver loop should be 1/5 of that. All right, but we're not talking about electrostatic field. We're talking about lines of force around. You have a 5:1 ratio, but it goes by area. 5 squared is 25, so your transmission, the transformation to 25 ohms. And you end up, oh, I got a 2:1, I can tune that out. Okay. On a mag loop, maybe you saw my curve that I published in the ham rag. If you're using a mag loop, as you 0.5 to 1, you have already heating the loop. It'll be warm. If you go to 2:1, you have lost 80% of your power to heat, and all that's being radiated is about 20 out of your 100. Tuned dead on. People say, well, every time I touch the tuning dial, I have to tune the loop. That's not true. Tune it to approx signals that are loud enough you can hear them. That idea that, oh, I'll go up 2K, hear plenty of signals. So you lose, that's 2 S units. So if you want to transmit to him, pull that loop dead on and do not use a tuner. Think about it for a minute. Suppose it could be a dipole, it could be a mag loop. Supposing it's mismatched up here, off resonant, and pick out my handy little tuner, put it on the output of my tuner resonant, boy, the transceiver is happy, it's 1:1. I ask you, what is the SWR from the output of the tuner up to the antenna? It's still way up there. You haven't reduced the losses at all. Then this whole line is tuned to 1 and the losses in the line are minima. You know it, 80, 40, 20 in the bands that you and I inhabit on HF, those losses are not significant. But when you get up in 2 meters, and bad coax is bad coax. And if you have bad connectors, they can look as bad as a short or an open circuit. If you buy cheap connectors you can buy, so that when you put it all together, it will be efficient at 70 centimeters. You know, too often I grab a piece of coax, that must be all right. It's not always all right. Sometimes you have a little leak you are. So all these things match up, but at higher frequencies, it's more important than at lower frequency. And I'd like to darken the room a little bit. Thank you, Matt. By way of a side issue, hello. Okay. When I was teaching school and teaching electronics, I wrote a bunch of understanding. And so I have several here that I'm going to show you that might be of interest. All right. I'm using an old program called GW Basic, and it is ideal for what I do because it's simple for a simple mind. All right, if I type files, I gotta type files. Did I get it now? Yeah. Wave oscillation. Did it come up? No. I can't see, Mike, to have a little more light. I didn't bring. Oh, so we can dim the lights, can't we? I got a light here. Oh, do you? Better. Yeah. Pro 5-piece wire of maximum current is at the center, perfect for coax. All right. This is your half wave. This is the current. It's maximum at the center. When the current is maximum, the voltage is, but the product is the same at any point along the line. And that's true whether you have SWR or not. The impedance, when you have SWR, goes all over the map. But the product between the voltage and the current at all points will always be 100 watts if that's what you're feeding into your antenna. All right, if I can. Now we're going to look at the same thing on 40 meters. What's at the center? Well, if this is current, what's at the center is very low current, very high coax. If you have a tuner at the transceiver, the oh, come on. I can't even. It might fail. All right, I'm going to do INTEFR, I think it is. Does it come up? See the waves? See the waves raise off a lot of gain? It's true, you can. Okay, you can get twice the radiation in some direction and half in others. You can't get more. Okay, that's fine. You wanted it on camera. That's fine. Okay. All right. Here we go. What you're seeing is waves emanating from the first antenna. And since I can't change the phase electrically, what I've done is I've moved the second antenna right where the first antenna is. So now I can change the. Can you see what's happening? You go to a point like this, both of these two sources are radiating it in phase here. But if you go to here, one is here, the other is off. One is here. That's a cancellation. So you'll see you have a number of places there where there are maximum radiation and minimum radiation in between. Let me go just a little bit further. You begin to see how the see, you can see the pattern. Look to the right. You see what you've got is you've got circle 1, circle 2 is right on top of it. So that's a maximum with this kind of spacing. And the spacing will tell you what the phase is. That gives you an idea of how you can get gain from two verticals. Let's run, I want to run, I can't find, OCF. Okay. Run, OCF, antenna. I put an equal sign. Oh. The program plots overlays the current for 40 and 20. And look what happens. There's 80. This point here is approximately, right there, can you see, is approximately 17% off center. And it's a pretty good match. Not perfect, not as good as a dipole, but it isn't that bad. Very usable. So you lose dozens, hundreds of hams have used them. But that's the reason. If you 15 and 10, they would also cross at that same point. So that gives you an idea of why the OCF antenna works. In the center, no good. In the center, 80 meters is here and looking 40 and 20 down here. We're going to feed it off center, which is compromise. Yes, a compromise, but not bad. All right, let's see if I can. View IER2. How did I type in? FOU. Oh, I want an FOR. ORIER2. See if RIER2. What you're seeing is the addition of a sine wave, fundamental, and then I've taken all of the odd harmonics and I've added them in. When you add them in, we've gone up to about the 17th harmonic. What's the shape of the wave now? It's a square wave. What do square waves produce? Wide band harmonics. So when you clip, you speak too loud and you clip the top of your audio on sideband, what you do is you're making a square wave out of it. Bingo! All of a sudden, you've got products, both sides of your carrier, way out. You start to sell a multiplicity of little sine wave oscillators, and they add them together. And with that, Dr. Fourier, who was a Frenchman, said, I can make any sound you want, any timbre you want, by adding together sine. And he had this complex programs you can run, which is not for us anyway. But this gives you a good idea of what happens when you add those harmonics. Now, when you overdrive your rig or over, what happens? You clip the tops, flat topping, what happens? You're going to have 2 times, 3 times, 4 times, 5 times. Where are we now? Okay. See if there's anything. Okay. Just for the fun of it, some of you are into satellite work or have been, and that would be Doppler. Yeah. What you're going to see is a model car move across the street left to right, emanating sound waves. The sound waves stay where they were started, but the car moves on. Meaning what you get is waves first copied LEO's, low orbit satellite. I noticed my picture would go to the right, then it would go to the left, sweep with the frequency of the satellite, and it worked out okay. Let's see if this comes up. DO, how is it spelled? where see the sound waves? Look behind, they're spaced out. Low frequency. Look ahead, it's too high. So when you hear the car go by, the first thing you hear is the waves in front. And when he goes by you, you're hearing the waves behind him, which are lower in frequency. All right. One more and have, no. There's my file. Okay. I'm gonna load motion of Mars. Mars is there, and the thing goes to the left, and then it starts back to the right again. It's because of the relative motion between the, let's see what happens here. I'll hit F2. Where is F2? There it is. This is what our line of sight is. See it go backwards? Now look at it come forward. Now watch it again. It's going to swing by and it reverses. So it looks like Mars has moved backwards, and it really hasn't. It's because we've caught up with it on our shorter orbit. This is called the retrograde motion of Mars. So if you're an astronomer, you know all about that. All right, I think I can stop it. One more just for the fun. This will bore you for about 2 minutes, but I'm going to show you what a simple sort is. You know, you get up on Excel or Works or Word, you know, you say sort, bingo, it's sorted. Well, I'm going to show you one of the poorest sorts, but it's the best to illustrate how it works. And what do I say? There's a number? Files. Where is sort? Stop was, should be here, it's not. I don't see it. Okay, not here. One more I could show you as am.mod2. Waves, 14.2. You put a varying signal on the audio line, the RF is modulated in step with the what's above. So it would be hard to show there, but AM is better anybody. Better anybody. I can turn that off. I can turn that off. Thank you, Kev. Oh, God. Whoa. All right. Anything will work. Anything can be improved. I wrote that quite simply, taking data and compare it a year. Quite simply, taking data and compare it a year later, a month later. Okay. A month later. Okay. SWR is always produced by what? Always. The one-word answer. That's the source. But the one-word answer is, come on, reflections. You can reflect off a non-resonant antenna. You can reflect off too sharp a curve in the coax. You can reflect over a bad connector. All points of an antenna contain what? You're feeding 100 watts to it. All points contain what? All points contain what? How about the impedance? Running a kilowatt with a continuous, the coax is warm. You can actually melt the wire. You can melt the dielectric so that it shorts to the braid. And 700 volts with a 100-watt drive. Now that's a lot. And the same is true along the line. The impedance ratio. If an antenna is too short, what did it has an excess of? If I have a 10-meter whip and I want to load it on 20 meters, it doesn't work. Why? Because it has too much capacitive reactance. What is, yeah, it does. It can be anything you like. X of P goes up, and that is the maximum point of maximum efficiency. What kind of feeder am I? It doesn't have to be. In general, what kind of feeder am I using? A very low feeder. What's that? Open wire or 100 to 1. You 500 volts on the plate or 1,000 volts on the. You could feed anything with. Now you got FETs or transistors, maximum voltage 20 volts, maximum voltage 50 volts. You're just protecting your transceiver, which is not bad. I used open wire underneath the E with about 8 feet of coax going in. Now I had high SWR on the 8 feet, but it was RG8 and I had like 2 dB loss. What's the impedance that mean? All right. 5 watts, mag loop antenna inside my den, inside the house. And there's a list of over here we have EA5 the snag. Worked all a lot more than you wanted to know.
Paul has a question.
Yes.
One comment, one of my favorite antennas is an inverted B because
Does it? And you put the current point where? At the top. The inverter V starts here with your tower or the post on the gable with your 8 feet off the ground with a piece of cord. Good
one
answer.
other thing I found is that if you have a 40-meter antenna, it will work fairly well on 15 meters, either vertical
Very well.
or horizontal. But that
Yeah.
isn't true on other bands, but they seem to have a relationship
They
where
do.
they work.
They do. Because on 40 meters, and there 40 meters it will have a halfway. 15 will have should. Thank you for listening.
Everybody for coming, and everybody got signed in, is that correct? Someone would like to get on the Zoom people, everyone, if you'd like to join us, just show up, and hope to see you next month. And I don't have my notes with me, but what do we have next month? I didn't bring my notes. Parks on the air, right? Thanks, everybody, and have a great evening. Yeah, just see how many might go to Jerry's. Yeah, how many people think we might go to Jerry's? 11.
Turn that off.
All right, guys, thanks for.
There you go. Okay, thank you.
Jerry, what's that?
That's connected.